In this experiment, I focused on the system stability analysis and how the location of poles and zeros affects the behavior of a system. And what I did first was identify and solve for the zeros and poles of the given transfer function manually. And I found that the zero is at s is equals to -4, while the poles are at s is equal to 0, 3, and -2. And after that, I plotted these on the complex plane to visualize pole zero plot. And then I analyzed the system's stability and observed that since one of the poles is located at the right half of the complex plane, the system is unstable. And I also used MATLAB functions like roots and impulse to verify my manual computation and to observe the system's impulse response. And from the output, I saw how the system response behaves depending on the pole locations and especially how it fails to settle when unstable. So while performing the experiment, I encountered some challenges, especially in understanding the concept of stability in relation to the complex plane. And at first, it was confusing to interpret why having even one pole on the right side automatically makes the system unstable. I also found it challenging to correct solve for the poles and zeros, since small mistakes in factoring can lead to incorrect conclusions. Another difficulty I experienced was connecting the graphical representation like pole zero plot and impulse response to the actual behavior of the system over time. So even though MATLAB helped visualize the results, I had to make sure I truly understood what the graphs were telling me instead of just relying on the software. So for my notes to self, I realized that the location of poles is very critical in determining system stability, and I should always remember that poles on the left mean stability, while poles at the right half mean instability. So I also learned that the farther the poles are from the imaginary axis on the left side, the faster the system's response decays. So moving forward, I need to practice more on solving poles and zeros manually to avoid mistakes.